Good morning, ladies and gentlemen, and good afternoon, ladies and gentlemen. um, Today, I have the pleasure to present you the project FlexChain. FlexChain is a German research project that deals with the blockchain-induced activation of small flexibility potentials in the low voltage grid. The project started in September 2020 and is founded by the German Federal Ministry for Economic Affairs and Energy. In August 2023, the project will end after a planned duration of 3 years. So my name is Shari Alt, and I am a digitization associate at the August Wilhelm Scheer Institute, which is a non-profit research institute in Germany that does research on many aspects of digitization. And in the Smart Energy Lab of the Institute, where I have my research focus, we research about the use of flexibilities in the energy systems or themes like software-defined energy in buildings, for example. So in the next few minutes, I would like to present more about the motivation for the project, the goals, the approach, as well as the current status. So afterwards, you are, of course, very welcome to ask me some questions. So let me start with the motivation for the project. Currently, a fundamental structural change is taking place in the energy sector in Germany. There is an increasing move away from centralized, dispatchable, large-scale energy generation facilities such as coal-fired power plants. And instead, the expansion of renewable energy such as wind turbines or photovoltaic plants is being pushed forward. But these renewable energies are high fluctuating due to their dependency on the weather and therefore more unpredictable in their energy generation. This fact poses problems for the balance in the grid and does therefore lead to an increasing need for grid stabilization measures on the part of the grid operator. But convenient grid stabilization measures such as grid expansion or hard control options are very costly for the grid operator and take often a long time to be implemented. For example, in the case of grid expansions. And these convenient measurements are very inflexible. So it will be a big challenge for the grid operator to handle the structural change in the energy system with these convenient grid stabilization measures. This is the motivation on the one hand, and on the other hand, there is a change in the role of the households in the power grid. They are changing from pure energy consumers to prosumers, which means producer and consumer in one person. And because of the increasing number of, for example, photovoltaic systems, heat pumps, or energy storage systems, or electric vehicle, the flexibility potential of the prosumer is increasing too. What flexibility potential means is that the time and the quantity of the electricity generated or drawn from an energy plant can be determined flexibility to a certain extent. So, for example, the time of charging an electric vehicle can be postponed by 1 hour, or the planned amount of electricity to be drawn from the energy storage system can be halved if necessary. Past research has shown that these small-scale prosumer flexibilities have great potential for stabilization the low-voltage grid. In addition, there is a high willingness on the part of the prosumers to activate these flexibility potentials, be it due to economic or intrinsic interests of the prosumers. And since the flexibility potential of prosumer is likely to increase continuously in the future, the use of these prosumer flexibilities represent a promising approach to the grid stabilization. And therefore, the FlexChain project aims at activating these small prosumer flexibilities and using them for grid stabilization. So if, for example, an overload in the power grid is foreseeable, the grid operator can react to it with the help of prosumer flexibilities. In this case, the prosumer could store the surplus electricity in their energy storage system or start charging their electrical vehicles, so that the prosumer takes more electricity from the grid than planned and contributes in this way to the stabilization of the grid. Because of the possibility to stabilize the grid intelligently and in a very targeted way by the individual households, FlexChain offers a great advantage compared to conventional measures. So the goals of FlexChain are to make these flexibility potentials of households usable for the grid operator so that he can stabilize the low voltage grid with them. And this is made possible by a trading platform on which the grid operator can place his flexibility requirements, and prosumer can react to these requirements with flexibility offers. The trading platform should be easy to use and as automated as possible to make a participation attractive for the prosumer. It should also enable economic trading of the often very small prosumer flexibilities and be used for targeted intelligent stabilization of the local grid, as mentioned before. Especially the aspect of economic trading of the small flexibilities was often a problem of projects in the past. The major challenge here is the small size of the prosumer flexibility and therefore the low economic value of these flexibilities. And if the transaction costs of the trade exceed this value, trading becomes uneconomically and uninteresting. So FlexChain want to meet this and other challenges with the help of the blockchain technology. Because the blockchain enables a decentralized trading platform that promises low transaction costs with high security, permanent documentation, and simple manageability. On the slide, you see on the left side the simplified concept of the project FlexChain. There is the household with its flexibility potentials, the blockchain, and the grid operator. And inside the house, the individual flexibility potentials are to be determined and controlled by a home energy management system, or short called HEMS. The data transfer between the household and the trading platform is done via a smart meter gateway, which will be installed as standard in Germany in the future. So the trading platform is symbolized here by the blockchain, on which the matching of the flexibility demand from the grid operator and the flexibility offer of the prosumer occurs. On the right side of the slide, you can see some of the research and development topics resulting from the FlexChain approach, which I have described before. These include for example, the development of an individual prediction or control of flexibility potentials through the HEMS. Another point of our research is the development of the blockchain technology itself and associated economic and legal conditions. Also, the expected economic benefits through such a blockchain-based trading system will be investigated inside the project FlexChain. And finally, there will be an evaluation and a field test of the FlexChain approach. Now I'd like to give you a little insight in the current concept state of the trading processes inside FlexChain. FlexChain has been running for about 9 months now, and we have made first considerations about the trading processes, and these are shown here on this slide. You see three main players here: the prosumer, the blockchain, and the grid operator. And for the prosumer, the HEMS is specifically highlighted as a key component. So in step 1, the HEMS, which is installed in the prosumer household, creates forecasts for the household's energy blends regarding their expected usage. So the result of this is a baseline. And this baseline gets transmitted to the grid operator. The grid operator uses the baselines from different HEMS for his grid simulation. In this grid simulation, he can identify potential grid bottlenecks to which the grid operator needs to react if he wants his grid to stay stable. To this grid bottlenecks, the grid operator can react with flexibilities from the prosumers. So he generates a flexibility demand in which he sets, for example, the location and the amount of the needed flexibility and send it to the blockchain. There, a smart contract will be generated, shown here in number 4. And via a push message, the HEMS, which are, because of their location, able to solve the grid bottleneck, get informed. So they receive information about the demand for flexibility that has arisen by the grid operator. And if a HEMS sees itself capable of responding to the demand with an offer, it sends these information to the blockchain. This offer gets stored as a smart contract, shown here in number 8. If the flexibility demand criteria match those of the flexibility offer, matching occurs and subsequently a transaction. As a result, the HEMS get informed about the flexibility it needs to schedule, and the grid operator get a confirmation too. Now the grid operator has the possibility to do a grid simulation again. In this grid simulation, he can check whether the flexibility traded within FlexChain is enough to solve the grid bottleneck, or whether more flexibility from the prosumers might be needed. In this case, he can send a new flexibility demand on the blockchain. And regarding the pricing of the traded flexibility, 2 options are being investigated within the project. In the first option, the price for the demanded flexibility is set by the grid operator based on a fixed price. And the prosumer can then decide whether this price offer is sufficient or is it not sufficient for him. The second option is a simplified auction. Here, the prosumer can actively influence the price. But which of the 2 options will prove to be more suitable for the project FlexChain will become clear in the course of the project. Next, I would like to briefly introduce the project partners of the project and their function inside the project to you. FlexChain consists of 5 core partners, all located in Germany. The consortium is led by us, the August Wilhelm Scher Institute. And beside the related organizational issues to this role, we are responsible for the conceptual design of the trading process, the development of the matching algorithm, and the smart contracts. Further, there are the companies Oli Systems and Vivavis, which are responsible for the development of the blockchain technology and its connection to the households and the network operator. Then there is the Hager Group, which is responsible for activating the flexibility potentials in the households. And for this purpose, the company's own HEMS technology will get used and be refined to include the required functionalities, like, for example, the forecasts. The 5th partner are the Stadtwerke Saarlouis, which assume the role of the grid operator and energy supplier. The Stadtwerke Saarlouis provides the grid informations which are required for the grid simulation. Furthermore, the Stadtwerke are responsible for the organization and the execution of the field test. So together, we want to give the grid operator with FlexChain an intelligent alternative to convenient grid stabilization measures. FlexChain enables effective and efficient stabilization of the low voltage grid by activating of small prosumer flexibilities and trade them in an economically way. So based on the increasing shift to weather-dependent renewable energies in Germany, FlexChain can be a crucial grid stabilization tool for the grid operator in the future. So I hope I could give you an impression about the FlexChain project. And if you have any questions, please feel free to ask me now. But due to the limited time, I also offer you the possibility to contact me by mail afterwards. Thank you for your attention.